Hey, what's up, guys? Mr. Myasis here. How you doing? How you doing? What is how you doing? You doing? How you doing, guys? I haven't been around for a while. Been really busy. So now getting back in the game, getting some of these videos out here. Let's see. What I'd like to talk to you on this video about is alpha level and confidence intervals, because I get a lot of questions about how do I determine the alpha level based on my confidence interval and my confidence level? So I'd like to talk a little bit about what confidence levels kind of really mean, and then how does the alpha level come from our confidence level? How do we figure that out depending on our hypothesis? All right, let's take a look at what I'm talking about. So I've got this blank screen here. And, because I'm going to write on it. Let's do it. So let's just take a reminder here that we are dealing with the normal distribution, right? And so I'm just going to use the normal distribution as my example here. I know that if we're using we're doing inference for means, we're using a t-distribution, but it works about this. It works the same way here when we're dealing with confidence intervals and alpha levels, because it really comes from the confidence level. So the t-distribution kind of looks like the normal distribution, but differs based on the degrees of freedom. We don't really have to worry about that in this case. All right, so just kind of backtrack a little bit. What we're interested in doing in a hypothesis test is we're interested in finding some burden of, we're trying to show that the alternative hypothesis is true. In order to determine if that alternative hypothesis is true, we're trying to determine if the p-value, the probability of getting a result like we did if the null hypothesis were true is so small that the null hypothesis can't be true. That probability is called a p-value. So really we're just trying to see, hey, look, is that sample that I took rare? Is it crazy? Would I even see that in random sampling? And how do we determine that? Well, if something is rare, like outliers, right? There's two ways to figure that. We can either use those fences things a long time ago, or if something is outside of 2 standard deviations from the mean. Now, how do we come up with that? Well, we kind of just said that 2 standard deviations from the mean is kind of our general rule of thumb for something to be rare. So what is 2 standard deviations above the mean? Well, if we're looking at our empirical rule, right, it's the 68, the 68, the what? The 95%, and then 99.7% is 3 standard deviations from the mean. But if we're looking at 2 standard deviations from the mean, we're looking at 95% of the population is within there. So what I'm saying is that if my sample was outside of that, then that would be a weird sample. That would be really weird that I would see that sample happening if the null hypothesis were true. So what probability would that need to be? Well, it would need to be not in this middle part. So what probability or less would that give me to say, you know what, it's not in here, it's out here somewhere, which makes it really rare. So well, what is that? That's what's left over from 95? Well, 5%. So what's left over, if this plus this, right, is 5%. And so if you've taken some statistics and they've talked about our basic alpha level is 5%. Well, they're getting that basic alpha level from the fact that 95% in between here is 2 standard deviations outside the normal distribution. Anything more than 2 standard deviations above the mean is going to be rare. So that's kind of our baseline. Now, it doesn't mean it always has to be that way. We can decide how much proof that we want. We can say, well, you know what? We want it to be 90%. All right, 90%. In that case, so 95% corresponds to an alpha level of 5%. Sometimes. Okay, so keep that in mind. We'll get to why I say sometimes. What's left over here? Well, left over is 10%. So if a 90% confidence interval will give me an alpha level of 0.1, and so forth. So in general, this is what happens. I saw this picture online. You see this picture a lot in stats books. That the confidence interval, the confidence level, right? This is the confidence level. The the confidence level, so alpha is what's left over, right? So if alpha is 10% here, confidence level is 90%, I get the confidence level. The confidence level is 1 minus alpha, right? If alpha was 10, confidence level is 90. If alpha was 5, confidence level is 95. All right, that is true because, and then this right here, what's this space left over? Well, we've got both spaces, so this is going to be alpha divided by 2, and this is alpha divided by 2, okay? So that's how we can determine, that's how confidence levels and alpha levels kind of go together. Now, here comes the tricky part. So, notice that both tails are shaded for this to be my confidence level. So this is true for a two-tailed test. But what happens if we're just looking at this part right here and we're looking at a one-tailed test? Then that's going to be a different alpha. Then what's the alpha level going to be? Well, what's the shaded area? What's the shaded area so that my probability makes me think, that's strange. That, again, that's the p-value. What p-value has, what does that have to be lower than in order for me to say, you know what, that's strange enough that I'm going to reject the null? It's going to be alpha divided by 2. All right? So that's going to be your alpha level. Tricky, right? Because you're like, wait a minute, how's the alpha level alpha over 2 if the alpha level is alpha? Well, we got to calm down, right? We do. We have to calm down. Okay? We got to figure this out given the context of the problem. So here's what we're going to do. I'm going to summarize this. All right? Here's what is happening, folks. Okay? Come on, man. Come on. What's up with my computer right now? So, let's suppose we have an alternative hypothesis that is a two-tailed test. All right? That means I'm going to use proportions for this case. Or actually, let me use a mean. Mu is not equal to, we'll just say 10. Well, let's do something weird. Let's say 13. All right? So let's suppose my alternative is mu is not equal to 13. My null hypothesis is that mu is equal to 13, or in some cases, if you're in some professor's class, they want to say, well, this is it. It's going to be equal. All right? So this is a two-tailed test, right? Because a two-tailed test comes from when I have a not equal to sign. So what is my corresponding alpha? Well, I need to know my confidence interval. So let's suppose that I'm dealing with a confidence interval. And my problem says that my confidence interval has a confidence level of 90%. What is the corresponding alpha level going to be? Well, let's think about it. I have a two-tailed test, all right? So the picture is going to look like this. 90%. What's left over on both sides, because I shaded both sides. What's left over? 10%. So my alpha level is going to be 0.10. That's pretty easy, right? So if I had let's say I had a well, I think you can figure that out. If the two-tailed test, and I set a confidence level of 95, then my alpha level would be 0.05, 5%. You just subtract 100, right? Easy. Subtract 100. How hard is that? Okay. However, if my null hypothesis was mu is equal to 13, or less than or equal to 13, and my alternative hypothesis was mu greater than 13. Now, greater than 13, that's a one-tailed test. Okay, this is a one-tail, upper tail test. So this picture is going to look like this. And I'm going to have 90%. Let's say I have a 90% confidence level. 90%. Then my alpha. All right, bam, 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 bam. Right here is the only thing I'm looking at, right? It's an upper tail test right there. So what is that? What's that value going to be? Well, if this middle is 90, then I have both sides left over is 10 total. So what's half of that? 5%. My alpha level is 0.05. Okay? So whenever you're looking for a one, and this is going to work the same way if it's lower tailed, right? If it's lower tailed less than or equal to, you're going to take and divide by 2. All right? So how do we summarize that? Well, the confidence level, all right, the alpha level, okay, for a two-tailed test is going to be, the confidence level is going to be 1 minus the confidence level, in decimal, of course. For a one-tailed test, it's going to be 1 minus the confidence level divided by 2. All right, so like I did here, right? 1 minus 0.9 is 0.1. That gave me the alpha level. Here, I did 1 minus 0.9, 1 minus 0.9. That's redundant. 0.9 divided by 2 is 0.10 divided by 2, which is 0.05, and that gave me the corresponding alpha level. So, how do you find the corresponding alpha level? Based on your confidence level? There you go. That's how you do it, all right? So, there you go, guys. That's alpha levels and confidence intervals. Anything else? Let me know. Catch you later. Don't forget to subscribe. Bye for now. Later.